When the production has failures, that is spoilage, the process costing method is modified slightly in order to assign manufacturing costs to spoilage units as well. Let's use an example to illustrate the weighted average process costing method. The example we use is from our textbook 18-30 in Chapter 18. In process costing, we first collect, determine, and organize physical production units information during the period. The information we need is from column 2 in the table. Some physical units information are not given and need to calculate. Work in process beginning inventory are 3,000 units. And units started in production are 25,000 units. So the total units in production during the period are 28,000. At the end of the period, the number of good units produced and transferred out are 2,500 units. And work in process ending are 4,200 units. Thus, some units are not accounted for, that is 28,000 units minus 2,500 minus 4,200 equals 3,300 units. These 3,300 units are spoilage units. Now let's determine number of them are normal spoilage or abnormal spoilage. It is given information that normal spoilage as a percentage of good units is 10%. Thus, normal spoilage units should be 2,500 good units times 10% equal to 2,050 units. Then we can determine abnormal spoilage units using 3,300 units minus 2,050 units equal to 1,250. After the physical units are determined, let's calculate equivalent units under weighted average method. Again, I'm going to use the setup we used in Chapter 17, one column for direct materials and another column for conversion costs. To determine the weighted average method equivalent units for each input, we need units from the work in process credit side, that is good, normal, and abnormal, and ending work in process units with the completion percentages. The credit side units are all 100% completed, and ending work in process units are 100% completed in terms of direct materials and 30% completed in terms of conversion costs. So the equivalent units for direct materials are 2,500 good units plus 2050 normal spoilage units plus 1,250 abnormal spoilage units plus ending work in process 4,200 units equal to 28,000 units. Note that 4,200 units are 100% materials used, thus no changes. As for the equivalent units for conversion costs, 2,500 good units plus 2050 normal spoilage units plus 1,250 abnormal spoilage units plus ending work in process 4,200 units times 30% equal to 25,060 units. Note that 4,200 units are 30% conversion cost used. Therefore, we use 30% here. Next is to summarize total costs of each input. Direct material costs total are 4,500 plus 46,250 equal to 50,750. Conversion costs are 2,700 plus 37,216 equal to 39,916. Next is to calculate cost per equivalent unit. Direct materials per equivalent unit is 50,750 divided by 28,000 units equal to 1.8125. Conversion costs per equivalent unit is 39,916 divided by 25,060 equivalent units equal to 1.5928. rounded. Combined together, the total manufacturing cost for a unit completed is 3.4053. Finally, we can assign costs to different types of units. Costs assigned to good units. $20,500 units times 3.4053 equal to $69,809, rounded to dollar. Costs assigned to normal spoilage units are 2,050 units times 3.4053 equal to 6,981, rounded to dollar. Costs assigned to abnormal spoilage units are 1,250 units times 3.4053 equal to $4,257. Costs assigned to ending working process are direct materials amount 4,200 units times 1.8125 plus conversion costs 4,200 units times 30% times 1.5928 equal to $9,619.